In previous videos, we solved a couple of problems of finding derivative of a complex kind of composite function using the chain rule. And now here again we are doing one more. Right here I have a complex, a kind of composite function, which is 5t to the power 9 plus 7t to the power 3 plus 2, and I need to find out the derivative of this function. And this is a complex, as I said, it looks complex because this composite function is itself carrying another function t, and which t is actually x to the power q plus 1. So this is the biggest function, inside which we have another function x cube plus 1, or you can say that t, which is x cube plus 1. Here t is representing actually x cube plus 1. If you look, it becomes something like this: y equals to 5x cube plus 1 to the power 9 plus 7 x cube plus 1 to the power 3 plus 2. Now we need to find out the derivative of this. And if you want to find out derivative without using the chain rule, it becomes very long. You need to first expand, and many of may have not learned binomial theorem to expand these things. So it becomes very complex to find out. So here we are going to use the chain rule, which is the a short method to find out the derivative of such kinds of complex functions. So now how to find out the derivative of this? As I used to say in previous videos, that if you are getting such kinds of thing, such kinds of function, then you imagine like the bigger function is your bigger fish, right? This is a bigger fish, and inside the stomach of this bigger fish you have actually smaller fish, which is t. So this t is my smaller fish. So first we have to find out the derivative of the bigger fish with respect to the smaller fish, and again we need to find out the derivative of this smaller fish with the constituent with which this smaller fish has been made. So this is x. So actually chain rule is something like this: derivative of the composite function y with respect to x is actually derivative of the composite function y, a complex function y, with respect to the smaller function u. We used to write in formula, but here we have actually another function t, so I'll be writing here t, and again derivative of that smaller function t with the constituent with what it had been made. So it is made with the x is the constituent, or you can say the component of the function t, so, or the variable of the core main variable, x. So this is a chain rule. In another language, if you want to say, the derivative of the bigger fish is actually, first you need to find out the derivative of the bigger fish with respect to the smaller fish, and then again you need to find out the derivative of the smaller fish with respect to what that smaller fish has been made. All right. So here what we need the two things here to calculate the derivative of this dy by dx. To calculate this dy by dx, we need two things: dy over dt, and we need to find out dt over dx. So let me first write what I have got. Here I have get y equals these things 5, and one more thing I have got, that is my t is actually what I need dy over dt. So let's find out dy over dt. And I hope now using the power rules and the sum rule together quickly. So since this is 5 and power is 9, so 5 times 9, that will be 45 times t, and power will be reduced now by 1, so it will be 8, and again 7 times 3, that is 21, and t's power will reduce by 1, so it will be t to the power 3 minus 1, that will be 2. And 2 is actually a constant quantity whose derivative is always 0, so there is no need to write 0. So we got here dy by dt, and now let's talk about the dt over dx. So dt is here, and now let's find out the derivative of this derivative of this t function with respect to the constituent. We're talking about the smaller fish, which is x cubed plus 1. So now it is simple, there is nothing, and there is to be 1, so 1 times 3, that is 3, and x power will be reduced by 1, so initially we have power 3, so it will be now 2, and derivative of the constant is 0, so I don't have to write this. Now I have now dy by dt also, and dt by dx also, so nobody can stop me to find out the derivative of this function dy by dx, right? So let's find out. It is dy over dx equals to dy over dt times dt over dx. Hey, don't try to cut this dt and dt. I have already told you this is one ratio and this is another ratio. It's derivative of the function y with respect to t, and this is the derivative of the function t with respect to x, so it's something different. Don't try to cut it. Well, now let's put the value. We have already got dy by dt here, so in this place we need to write this value, which is 45 times t to the power 8 plus 21 times t to the power 2, right? And now let's write another one, dt over dx, which we have already find out, 3x square, so times 3x square. Well, here t is actually x cubed plus 1, so now in the place of t I can write that 45 times this x cubed plus 1 to the power 8, and then again plus 21 times t is actually x cubed plus 1, so x cubed plus 1 whole square, and then times, actually this is the biggest bracket, times 3x square. Alright, so now you can write even in more appropriate way. There are many methods to write anyhow you want, just write it. Okay, so dy over dx, what actually the question is asking me to find out initially, right? This dy over dx of this is now this is 3x squared, so you can individually multiply also. First this will multiply this part, so 45 times 3, it will be 135 x cube, sorry, this is x square, so it will be x square and then x cube plus 1 to the power 8, and then plus this, again this 3x square will multiply this part, so you'll get 21 times 3, that is 63 x square and x cube plus 1 whole square. So this is our derivative that question is trying to ask us. They had just tried and we finished. Here we are. So we'll be doing a couple of more problems and we'll be finishing more and more tough problems by using chain rule. Okay, goodbye.